Greetings to you, all my viewers. Welcome to Jono's Challenge series, where we try to dig deeper into the geometry nodes potential and learn a lot of things by creating a cool project like the one you see in this image. So, what is this all about? I found a question on YouTube video if you can make a particle stick to a surface using geometry nodes. So in this 4-part series, we will dig into this problem and we will recreate all the details that you see in this awesome project. Before starting, I want to quickly show you what you'll find in the project available on Gumroad. This is the finished setup. Let me switch to a tab that is less demanding on the system. So you will have a lot of controls on this master object. Controls regarding the mesh, you can use this on the geometry that has the modifier, or you can use an outside geometry, and you can scale, rotate, position this object. You can even use a crease to keep the shape if you use something more squarish. Of course, you have controls for the pedestal on which the mesh is positioned, and then you have controls for the animation, what frame to start, how long it should last, what will be the offset between the drops, or whatever you want to decide to put on your mesh. And then you have controls for these paths that the drops will follow. A bunch of controls, where to start, where to end, how far apart should be, and stuff like that. Of course, you have controls for the water drops, the scale, and if we go a little bit further into the animation, you have these droplets, and you also can control their distribution, sizes, and density, stuff like that. So a lot of controls. And on top of that, if you notice this white dot, you have another geometry node setup that allows you to parent the camera and follow one of these drops, whatever you want. You see this white dot moving. It's a very simple control for this, let's say, camera rig. So lots and lots of stuff in this project file that you can use to learn or to create new things. So let's switch to another setup, an empty setup, and about this series, a 4-part series, will cover basically everything you saw in this project. So if you don't want to purchase the project file, don't worry, you will not miss anything. You just follow this series and you will find all those details that you saw in the video in these tutorials. Also, a quick word of thank you for all of you that are subscribing to this channel, commenting on the videos, liking the videos. This really helps the channel grow. So thank you very much for doing so. And if you find this content valuable, don't hesitate to do all those stuff to help me keep doing this stuff. So let's get started. What exactly we will cover in this today's series, I'm going to show you in a moment. But let's find first the answers to two questions. So we have a mesh. Doesn't matter what mesh, and we want to have a particle that sticks to this surface. So how can we do this with geometry nodes? Obviously, we have to find a way to transfer the information between these two, like the position from this mesh to this one, and make this one aware of the location in space of the other one. And we have two nodes that can help us do that. We have the geometry proximity, and we have the raycast node. And during this series, we will use both of them. So let's see what happens if we try to stick some geometry to a mesh. So let's quickly go to edit mode for our setup and add a monkey head. Tab out of edit mode. So now we have this sorry, I think yeah, let me get out of this mode. So we have now a monkey mesh here on our setup, and let's say we are not going to use for now the raycast. Let's say we want to take a simple icosphere and we want to make it stick to this surface. So let's make sure we see both geometries. Let me make this one like a lot smaller, and in order to see things clearly, let's set material. Let's make this one red, and let's make this one blue. Now we can switch to material preview, and we have this icosphere. Let's push it up so we can actually see it, and we have this setup here. And now we want to make this one stick to this surface. So how can we do that? Well, we have this geometry node that is basically a simplified version of the raycast that takes a target, let's say the monkey, and outputs two things, the position and the distance. And it's comparing these meshes based on, obviously, proximity. So it's kind of easy to understand. So let's say we want to move this icosphere in regard to this one, to stick it to the mesh. Let's do something like this. And as you can see, if we switch to wireframe, we get this one stick to the surface, but it's squashed because this node looks at the position of each point. You can't use a transform on that. They are totally different. If you try to plug this one here, you'll get a red noodle. So how can we overcome this problem? Well, we can do a geometry to instance. That will make this thing be treated as a whole. It's going to look at the object, not the points. And now we have a nice control that can make the point stick to the surface. We see it sticks to the surface, all right, but it's kind of moving in an erratic and unpredictable manner. So although this method is good, that we can make this particle or any number of particles stick to the mesh, we can't really control this, their movement. So this is the question number 2. How can we control more precisely this movement? How can we create a path that these points will follow? Well, we have nodes that can create a path. We have access to curve objects, and we can mix these methods. We can create a curve object, and then we can use a proximity to make the curve stick to the surface, and then use that curve as a guide for our object. So this is basically what we are going to do in this series. So that will be the topic for today. We kind of find an answer to the questions how to make an instance follow a surface in a precise way by using a path. And today we are going to tackle these points. We will create the guidelines, we will make them stick to the surface, and then we will make an object follow those guides. So let's get started. We will start with this part, moving the guidelines, adding the guidelines. So let us get rid of these nodes for now and start again. Okay. There are many ways we can make a bunch of parallel lines using geometry nodes. I kind of want to show you an interesting one. Let's start with the grid, and let's reintroduce this join geometry nodes so we can basically see both stuff that are going on. Okay, let me connect this one here, and I'm gonna take a geometry transform node again to push this one up, And in order to, now actually we don't need the material. We will turn this geometry into a bunch of lines. So let's switch to wireframe view to see what's going on. We can mute the monkey for now. Let's see. If we look at the monkey, we basically want the lines to go this way. So looking at this plane, we understand that we don't really need 3 vertices on the y. We kind of need more vertices on the x, something like that. So now we basically have some lines. We can now convert it to a curve using a mesh to curve node, because we will need some things to do with this. Basically, we need to end up with a curve, and we will need a bunch of other stuff, but let's not get ahead. The question is, how can we get rid of these parts, these edges here? And that's the cool part about why I want to show you this method. Let's take a delete geometry and let's switch it to edge, and we want to delete some edge based on a selection, and we will use for that the index, because there is an interesting thing how this mesh is built, and you will see it quite soon. Let's introduce a compare node because we want to create a Boolean mask, and let's take the index, switch this one to integer, and look at what's happened. Let's say right now we are deleting everything that is greater than 0. So look what happens. Right now we have what we want, and we start to get these lines now if we just go like this. So we understand that the mesh is built like this. First we draw these vertical lines, and then we start to draw the other ones. So if we find the last vertical line, then we can create our mask. And the last vertical line, looking at the points, we see we have an index from actually I want to see these ones, so let me mute this one first. If we look at the edges, we see we have 6 edges, and it's obvious because we have 6 vertices on the x, and they have an index from 0 to 5. So we can see this, that everything that is greater than 5 gets deleted, meaning these edges. So we can easily create a procedural setup by using a integer, taking this value, plugging it here, and then we can plug this one here and simply take into account the fact that the index starts at 0, and we can subtract 1. So we get this index of 5. So now no matter how many edges we have, we created this awesome mask that will make things work the way we want it. So that will be the first part. We kind of have our edges now. So it's time to move to the second point. Make those ones, these edges, adhere to the surface. And now you'll soon understand why we need curves. Not only because this is what our mesh can follow, but if we make this stuck to the surface, and for that I'm going to use a raycast and not a proximity, because we want to have a little bit more control. So let's just use a set position, and we want to target our mesh, a monkey, and use this hit position to be the position of the new lines. You see something happening. If we switch to wireframe, we see what's the problem. We get this stuck to our mesh, but If we look at our splines, we have 6 splines and 12 points, and it's easy to understand what's going on. We have a point here and a point here, and those get stuck to the mesh, and the line between them is just straight going through the mesh. So that means we need to add more geometry, and we can simply do this using a resample curve, and we can switch this one to length, and let's add more density to the line. And as you can see, our lines now get stuck to the mesh. Why we did it like this? Because if we would use the original mesh, then we will still need line later on, and we will basically have to do subdivide mesh to get geometry for this, and then turn that to mesh. It's more computationally intensive. So right now things seems to be working fine. We have a bunch of problems here. If I switch to wireframe, things looks nice, and they look okay. But if we start to play around with this setup, so let's say we want these lines to be longer. So let's increase the size of this plane on the X. Let's make it something like this. At the end of this video, I'm going to show you how you can make the setup smarter. I'm going to show you in detail what I did in the final project. Right now, we will just push manual values to move faster. So by increasing that length, we can make the lines longer, and we can play with the size on the X to control the spacing, basically, as you can hopefully see here. But let's leave it at 1. And this value is important because we have to have the mesh above our target mesh, our lines above the target mesh. And if we play with this value, we can control the position on the mesh. And this is what I want to show you. If we push it like this, things look nice, but it's obviously we won't want this kind of mesh at the end. We will want something smoother. So let's add a subdivision surface. Control click to move these noodles here, and watch what happens when we have more details on our mesh. Something like, let's put level 2. If we look here, we see that the lines are not sticking to the mesh in this part, and that's the first problem. What is going on here? Well, if we look at this ray cast node, we have a ray direction, and it's set to z-1, meaning that we start with this line and we shoot a ray straight down. And that creates our problem, because we are going to hit this point and we are going to hit this point, but we are never going to hit these points if we go straight down. So we basically want to take this y-axis of the ray cast, and instead of making the ray go straight down, we want to make it go something like this, so we can hit these points. And it's easy to do this. Let's look at the mesh like this and play with the ray cast direction. And sure enough, we can see it stick better to the surface right now. Be mindful, if you go too far, you will start to lose this side. So it's a tweaking game. It's good for this project for making drops follow the surface, but at the beginning of the next video, I'm going to show you a way to make sure that you actually stick these lines perfectly to the mesh. But that's not in a project on the Gumroad, by the way. It's just something I discovered after I finished the project. I'm going to show it to you. But basically, this is what we need to do. If we switch now to the wireframe, playing with this value kind of emphasizes a problem. Now we have all the lines sticking in the middle, and that's going to be a problem when we want to make our water drops follow the line, because they will go inside of mesh when we don't want that. So let's quickly delete that point that it's converging, all of those points converging at the world origin. So delete geometry point, and we want to build a mask based on position, because we know the position of that point, and that is 0, 0, 0. So let's do a compare. We can leave it like this, conversion to float, because the average of 0, 0, 0 is going to be 0. And let's say if it's equal to 0, we want to delete the point. And if we switch the mesh and look at it, we kind of actually have to do this after we do this thing, after we stick it to the mesh. So the location is important. Okay, once we do this, we can see these points just get deleted. So we fix this problem. Now we can play with these values to move this where we want, something like this. And let me just do something like this until we get something that it's looking like this. So now we have a variation on size, the length of the lines, and they stick nicely to the mesh. So we basically completed our objective. Now that we have a spline that we want to follow, and we managed to fix this also the position on the mesh, we are going to go to the next point and make the instances stick to these lines. Something else that you can do if you want. Now that we have this path, you can play with it. So let's say I do a set position, and it will be wise to do it before we stick it to the mesh, because we want to keep this attribute of the lines. You can do a little bit of deformation of that if you want. So let's say we take a noise texture, and we want to deform these lines by pushing them in the direction of the normals, and we are going to use this noise texture as a scale. So let's switch this on to scale, and this as a factor. And as you can see, we get a lot of deformation. We can switch, when we can stick here a strength control, something like this, and now we can play with this value to get less deformation. So now you can make wavy patterns and stuff like that if you want, something like this. And yeah, that gives you a lot of control. We are not going to do this for this project, but I just wanted to show you what else you can do. So now we have these lines, and we want to make some instances follow those lines. So how are we going to do that? Well, we can use an instance on points. We are going to use these points. Let me plug this one here, and because we still want to visualize these lines, let's connect this also here. And now you have a bunch of ways you can do that. You can sample these curves and get a point and transfer that position to your object, or you can do what I'm about to do, identify the end of this point, these lines, and stack a mesh to that point, and then control the splines with the trim. So how can we stack it to the end? Well, we have this endpoint selection mask that we can plug here, and now we can use let's see, an icosphere. Let's make it like a lot smaller, and oh, sorry, I want to push this to the selection. And let's add a material to this to easily see these icospheres. And you can easily see what this node does. It's deciding based on the this criteria how far you are from an end of the line. And you can decide how many instances you have, like the first 5 points will have an instance and the last can have nothing, and anything you want you can do it here. So let me make this one like smaller, something like this. And now we basically have the basis of our effect. We have the drops here, and the way to control this, it's going here and controlling the spline that we are using as a base. So if we add a curve, trim curve, and we plug it here, this will be basically our controller for the entire animation. You see what's gonna happen if we play with this start value, for example. If we put it to 1, everything goes up. And that's exactly what we want. If you want to push these points further, you have to play with this mesh. And let's say we want to move it on a certain location. It's a kind of a very sensitive value. Something like this. Let's say we want to start like this. Okay. I'm going to show you, like I said in the end, how you can make this more procedural to have less parameters to control. But you get the idea. Now we have this slider that can control the animation. So let's build the animation as well. Let's use this frame and pass it to through map range. So plug this one here, and we want to start at 1 and end at 0. See, because we kind of want to do this. So this is the bottom part is the output of the node, what it will output, and this is what is the input of the node. So on the output we can control what's going on here, and on the input we can control now, given the fact that we plug the frame, when we start and when we end. So let's say minimum it's the starting frame 1, and we want everything to last like 120 frames. So now on the course of 120 frames we have our animation playing, something like this. So everything is sticking nicely to the surface. We have a control over the paths. As you can see, we can deform it. We can decide how many we have, where they start or where they end, and a bunch of other controls, because we are working with splines that are great for that kind of stuff. And now we have an animation. The final thing that I want to show you is how you can make this animation a little bit more interesting, because now everything starts at the same time, and the only difference is given by the length of these lines. That's why you see a little bit of an offset, but we can play with that in 2 ways. We can either offset them as they are outputted by doing something in this range, or we can do something in this range to offset. And that's going to work because we are basically now generating values for each individual spline. So if we look at this geometry with the viewer node and we check this one here, right now we have the same value for all, but as you can see we have 6 values, so we can modify those individually. So let me show you what I'm talking about. Let's do a math here, and I'm gonna subtract something from here. Now you can see we can control the values here, and if we play with this by adding a random value, we will start to generate a random value for each and every value here. So let's say we want a random value from 0 to a maximum of 120 frame deviation. So right now, as you can see, things get offset because if we look at this value, we no longer have, like here, the same value. We subtract a random number between 0 and 120 in this case from this constant frame number. So now we get a bunch of values here, as you can see, and that will have as a result that we will have an offset between these drops. As you can see, some of them starting earlier and the other one are still waiting. We can see now that these two values are closing to 0, so that means these points will start to work their way down, as you will soon see. So this is how you can offset the animation. That's gonna be our animation module. Let me frame this one and press Ctrl S. That's a lifesaver. Great. This is everything I wanted to cover in this part. Next part, we will do a bunch of very interesting stuff. We will do some sculpting, make this icosphere look like water drops, more like water drops. And we will start to implement other stuff, like we have this path and we want to utilize them to the maximum to create the water droplets. How we can make the water droplets appear on this path behind the water drops. And we will do that procedural pedestal that you saw in the demo. We'll start to work on that. So a lot of sculpting, and also some problem solving, how to make the water droplets stick to the surface, and that's gonna be very interesting. So I'm waiting for you in that that part, and hope to see you in the next tutorial. Now, if you want to stick around, I'm going to show you how I made this setup smarter. That's going to be the last point to be touched today. So for that, we will go back to the finished project. So hope to see you in that also. All right. Thank you for staying. Back to the original project. Let's see how I made things smarter. First of all, we have this possibility to switch between the target self, meaning the geometry on which the geometry nodes reside, or something else that you can control from here. And also we have this control over the subdivisions. And we also have this possibility to crease stuff, and yeah, we are going to look at that. How can we do this? We have this object info node that allows us to pull inside of the geometry nodes an outside mesh, and you can expose a parameter by simply doing something like this. You can drag and drop into this empty socket a noodle, and then you press N and you go to the group tab, and you get this one here. You can change the name to whatever you want. You can put a tooltip. I did this with everything, so you can understand what every parameter does. You can set a default, minimum, and maximum, and all that good stuff. So this is basically what you will do to add a connection. So what I did, I created this switch here that is switching between the geometry, inside geometry or outside geometry, and I exposed this objectivo object, so you can select it here, anything you have in your project file. After I did that, I added the subdivision and I exposed that, also the crease, to control how smooth the mesh is, and basically how much of the edges you keep. So this is that part. How I created all these controls for the path. Let's look at the path and animation. As you can see, you can adjust the path direction. That's just exposing from this raycast node the ray direction, and we have this adjustment: length, start position, side offset, spacing, all this good stuff. So you can make this one to be shorter, as you can see here, something like that, or you can adjust the start position for the drops by playing with this value here, and you can adjust if they are set to the left or the right, and it's going to work regardless of the mesh you plug here. And why? Because we made the entire setup aware of the geometry by using a bounding box. And then I did a bunch of stuff. For example, to have a procedural way to know how long the lines have to be to cover the mesh, I calculated the length on this axis, on this axis, and then I just doubled this value to get the maximum possible length for this array. And the way to get the length on the one side is to subtract from the maximum the minimum, and I did this for all the axes. Then I added them together and double it and got this, like I said, for the length. So now if we look at this length and we see the parameter length is basically multiplied this length that we calculated with this 0 to 1 parameter. So at 1 multiplied by 1 we get the maximum value, and as we multiply closer to 0 we get just a fraction of this. So this is how I created this parameter. As for the starting position, this is an interesting one. By trial and error I found out that pushing this, basically because this is what we are doing, we have this grid and we just have a transform node, and by pushing this grid on the y direction we can make the raycast touch these parts or these parts before the grid is finished, because if we have a grid with this length, that means we can maximum touch this point or this point. So if we translate this mesh this way, for example, and we put it like this will be the final point that we can touch, and we can touch a starting point something like maybe here. So by playing with the y position of this, we can decide where the line starts and where the line ends. And by trial and error I found out that in order to hit the maximum points here, you kind of have to go half of the length of the grid this way, and to touch this point you're gonna have to go like 3/4 of the length of the mesh here. So this is what I did for the start position. As you can see, I put a minimum that is approximately half of the length of the lines, because this length controls the size on the y of our plane with which we started the grid. So it's approximately dividing that length with 2 and some more. And to calculate 3/4, I divided by 4 and then multiplied by 3. So I got 3/4 approximate values. And of course, I had to invert those values. The offset on the x is this spacing that we have here. Path spacing is just controlling the size on the x passed through geometry nodes, and you can decide the minimum and maximum. And the xy or x offset is just pushing that mesh between one side and the other. And in order to make it procedural, I kind of did the maximum possible width of this input mesh, and I pass it here. For the minimum is the inverted value, and for the maximum is the real value. And I decided for a range from 0 to 1 because this kind of made sense for me. At 0 you have no offset, at -1 you have maximum left offset, and at +1 you kind of have the maximum right offset. So this is how I constructed that parameter. Again, in order to make sure that everything works, we have to have the original lines above the mesh that we are targeting, and this is what I did. If we look here, I use the bounding box again to get the maximum possible Z height, and just to make sure, I added a constant that you can actually leave at 0 if you want, and it should still work. But if you add a little bit, you get more reach to the mesh, to the back sides or the front sides of the mesh. So this is how I constructed these parameters. For the animation parameters, the one marked by A, it's actually very simple. If we look at the purple frame, I just exposed the seed of this random node and the maximum value from here, and of course the frame range, minimum and maximum. They are here in the animation, as animation start and animation length when it finishes and all that good stuff. So this is what I did to make the setup smarter. Thank you again for watching this part, and if you find the content valuable on this channel, you can help it grow by liking, subscribing, and commenting on the videos. And of course, you can support me by buying the project file from Gumroad. Until the next video, have a nice day and happy blending!